Section 8.1, Monomials and Factoring. Our essential question is how do you find the GCF of monomials? Our first vocab word is factored form. Factored form for a number, or for a monomial in this case, is what you find at the bottom of a factor tree. So hopefully from a previous class, you remember how to make a factor tree. If not, I'll show you an example. For the number 12, you could break it down into factors, 4 times 3, and then 4 you can break down again to 2 times 2. So factored form for the number 12 is 2 times 2 times 3, or 2 to the second power times 3. So factored form is when you break down a number into a string of prime factors. So it's the prime factorization. GCF, hopefully you remember, stands for the greatest common factor. So, greatest meaning the biggest, common meaning something that they share, and factor as in the factors of a number. So it's the biggest factor that is shared. So it's the largest shared factor, and it could be of 2 or more terms. Okay, factor the monomial completely. 12. I just used that number on my last example. So 12, you could break down into factors 4 times 3, or this time I'll use 6 times 2. 6 breaks down again into 3 times 2. And I'm going to bring down this 2 that was prime. You keep on factoring a number until you've gotten to prime factors, all prime factors. So the numbers 2 and 3 are both prime, so I'm done factoring those. Now, x to the 4th power, hopefully you recall, means x times x times x times x. And y to the 3rd power would be 3 y's multiplied together. So, when it says factor the monomial completely, this is what we're looking for. The next one is a negative number. When you're working with the negative number, the first thing that you need to do is factor out the negative. So, -1 times 20. Then I can factor the 20 into 5 times 4, and the 4 into 2 times 2. I'm going to bring down these prime factors. So there's my prime factorization for the number -20. -1 times 5 times 2 times 2. I've also got x to the 3rd, and then I've got y to the 2nd. Our next example says to find the GCF. So to find the GCF, I'm going to factor each of these. So 12 was 4 times 3, or 2 times 2 times 3. And then I've got 2 A's, 2 B's, and a C. The next one, 18. 2 times 9, and 9 is 3 times 3, and then I've only got 1 A, and I've got 3 B's. So, to find their greatest common factor, I am going to circle everything that they have in common. I see a 2, I see a 3, an A, and 2 B's. So their greatest common factor, what I've circled on each one of them, I've circled a 2, a 3, an A, and 2 B's. So that means the GCF is 2 times 3 is 6, AB squared. 6AB squared. That's the greatest factor that is common to both of my terms. Okay, the next one, 6xy to the third, 2 times 3 times x, and then 3 y's, and 18, 2 times 9, 9 is 3 times 3, times y, times z. Okay, what do they have in common? They have a 2, a 3, and a y. That's it. So the GCF, 2 times 3 times y, or 6y. It's my GCF. Next, I have 11, which is a prime number, so I can't factor 11, times a squared times b. 21 is 3 times 7 times a, b to the third power. So there is not a coefficient, there's not a coefficient in the GCF on this problem because they don't have a coefficient in common. 11, 3, and 7, I don't see anything that they have in common. All that they have in common is 1a and 1b, so a times b, or ab, is the GCF of these two terms. Okay, word problem, our favorite. A florist has 20 roses and 30 tulips. So 20 roses, 30 tulips. Okay, what is the greatest number of identical bouquets she can make if she uses all of the flowers? That's the first question that we need to answer. Then, the second question, how many of each kind of flower are in each bouquet? So she's got 20 roses, 20 roses. I can factor 20 into 5 times 4, or 5 times 2 times 2. I can factor 30 into 5 times 6, or 5 times 3 times 2. So the GCF, the greatest common factor, looks like we've got a 5 and a 2 in common. So the GCF is 10. So what that means to me is she can make 10 identical bouquets. Okay? And what's going to be in those bouquets? Let's think about that. If she makes 10 bouquets, she's got 20 roses. And if you're dividing it into 10 bouquets, that would mean 2. So 2 roses. And if I have 30 tulips divided into 10 bouquets, there would be 3 tulips. In each. So 10 identical bouquets, and each bouquet of flowers has 2 roses and 3 tulips in it. And then she's used all of her flowers, and she's made bouquets that look the same. Because you would not want to have people fighting because their bouquets didn't look the same, especially if she was giving them to 10 friends. Okay, you should be able to write a summary now. And here are your homework problems.